I am Tangashakti from AAA Department, Rohini College of Engineering and Technology. Subject code is EE8591 Digital Signal Processing. So in this video, we are going to discuss about architecture of digital signal processor. So from this session, the students can able to understand the architecture of digital signal processor. So the digital signal processor is a specialized microprocessor chip with its architecture optimized for the operational needs of digital signal processing. DSPs are fabricated on mass integrated circuit chips. A digital signal processor and microcontrollers are microprocessors that are programmed to execute specific tasks or applications as assigned by their user. So this is the block architecture of digital signal processor. So here these are the memory and this is the CPU, and here this block having peripherals. So the CPU consists of parallel logic unit and central arithmetic logic unit. It will be represented as CALU, auxiliary register arithmetic unit, program counter, status register, and a 16 cross 16 bit multiplier, 32 bit accumulator and 32 bit accumulator buffer, and shifters. So first we are going to discuss about parallel logic unit. So the parallel logic unit is a second logic unit that executes logic operations on data without affecting the contents of the accumulator. It can directly set clear, test or toggle multiplier bit in a status or control register or on a any data memory locations. It performs Boolean operation or bit manipulations also. Central ALU, central arithmetic logic unit. It consists of 32 bit ALU, 32 bit accumulator, 32 bit accumulator buffer and 32 bit product register, 0 to 16 bit parallel shifter and right parallel shifter and left parallel shifter. So normally the 32 bit accumulator and arithmetic logic unit perform a wide range of arithmetic and logic functions, the majority of which execute in a cycle. Next one is auxiliary register arithmetic unit. So the auxiliary register arithmetic unit contain 8 16-bit auxiliary register, which will be represented as A or 0 to 7, 3-bit auxiliary register pointer, 16-bit index register and a 16-bit auxiliary register compare register. So normally the auxiliary registers are used for indirect addressing of the data memory or for temporary data storage. Next one, program counter. So the program controller contains a logic circuit that decodes the operational instructions, manages the CPU pipeline, stores the status of the CPU operations and decodes the conditional operations. And it consists the following elements: program counter, status and control registers, hardware stack, process mode status register and circular buffer control register. So next one, multiplier. So normally this block can multiply two 16-bit numbers and it's also multiply the signed and unsigned multiplications also possible. Next one, status register. So here two 16-bit status register contain status and control bits for the CPU. So next one, program controller. So it's having counter, status and control register, hardware stack, address generation logic and instruction register. So the hardware stack is a 16-bit wide and 8-level deep and is accessible via push and pop instructions. So the stack is used during interrupts and subroutine to save and restore the PC content. Next, address generation logic. So it contains the code for application and holds the table information and immediate operands. So next one, status and control register. So the C5X has 4 control and status registers. They are circular buffer control register. So next one, program memory. So the program memory is here 16-bit on-chip maskable programmable RAM. So the program memory can reside both on and off chip. So it's having 3 types: program memory, data or program dual access or AM, data or program single access. So data or program dual access ROM has 1056 bytes of data program dual access. So the data program dual access can be read and written to in the same machine cycle. Next one, data program single access. So it can be configured by software in one of the 3 ways. Next one, on-chip peripherals. So here we have clock generator, hardware timer, software programmable wait state generators, general purpose input output pins, serial port interface, buffered serial port, time division multiplexed serial port, host port interface, user unmaskable interrupt. So first one, clock generator. So the clock generator consists of internal oscillator and a phase lock loop circuit. So the clock generator is driven by a crystal oscillator circuit or by an external clock source. Hardware timer. So the timer is on-chip down counter that can be used to periodically generate CPU interrupt. It can be stopped, restarted, reset or disabled by specific status bit. Next one, software programmable wait state generators. So these generators can extend external bus cycles up to 7 machine cycles. Next, shutting off the internal clocks allow the circuitry to run with low power consumption. Next one, general purpose input output pins. So the C5X has 2 general purpose pairs that are software controlled. And serial port interface. So different kinds of serial ports are available: a general purpose serial port, a device, a time division multiplexed serial port and a buffered serial port. So next one, buffered serial port. So it's available on the C56 and C57 devices. It operates on either auto buffering or non-buffered mode. The auto buffered mode allows high-speed data transfer and reduces interrupt latencies. So next one, time division multiplexed serial port. So the TDM serial port interface is implemented on the C50, 51 and 53 devices. It operates in either TDM or non-TDM mode. So the TDM port provides a simple and efficient interface for multiprocessing applications. Next one, host port interface. So it's an 8-bit parallel port used to interface a host device or host processor to the C5X. Information is exchanged between the C5X and the host device through on-chip. User unmaskable interrupt. So the interrupts. So the user unmaskable interrupts are generated by the timer, the serial port, the host port, and the software interrupt instructions. Okay, thank you.